Welcome to my video on setting up the SkyX Professional for your telescope equipment. Recently on the Software Bisque website there was a thread about the use and utility of video tutorials for setting up the SkyX in addition to the more traditional manuals and searching on the website. Now, I personally don't find videos to be terribly helpful because I can generally read a lot faster than I can talk or listen to somebody else talk, but I thought I would give it a shot and see if I could help some people out. You know, the old saying, if it helps just one person. So with that one person in mind, Jean-Claude, this is for you.
Hi, welcome to the video. Before we get started on the software side of things, I wanted you to see the hardware that we were going to work with. Since we're going to be doing a lot of screen imaging, you're not going to see the actual hardware, you're only going to see the screen. So this is my main imaging rig. It's a Stellar View SVQ100, so it's a 4-inch refractor. It's a Chinese-sourced quad, so it has 3 elements in the objective, and then it's got an additional element back here that's a field flattener. It's sitting on top of a Takahashi EM200 mount that I've had for about 12 years now. And then on the back end of the telescope, we've got a Feather Touch focuser. It's a 3-inch focuser. We've got a Feather Touch motor driving it. And we also have the Feather Touch controller, the Focus Boss 2 controller. The camera is a QSI 690 WSG8. So it has an 8-position filter wheel in here. And then the guider is the ubiquitous Starlight Express Lodestar X2. It's also sitting inside of Gary Jarrett's KISS focuser, which makes focusing the guider very, very convenient. Now, in addition to the equipment that you're looking at here, I've also got a power box, which is located right here. Now, the power box people sometimes make fun of, but it works pretty effectively. I've got 2 power supplies, a 24 volt for the mount, 12 volt for everything else. I've got a USB serial converter, and then over here I've got the Optec Feather Touch focus controller right here. So it's the Focus Boss 2 or it's the Optec Focus Links, depending on who you buy it from. And then I've got wrapped up in blue painter's tape is a powered USB hub. So the idea is that the only data connection from the computer is this one USB line right here. And then it comes into the hub and everything else gets fed out of that hub. Keeping it in the box allows the equipment to stay relatively warm in the winter. And then in the summertime, I just take the lid off and it cools right down.
So before we can use the SkyX Professional, we actually have to download it and install it on the computer. The installation process can be confusing. What you need to do is you need to find the most recent full installer. And then you're going to need to find the most recent update, and then potentially you're going to need to find the most recent daily build. There's a variety of ways that you can do this though. So for instance, the most recent full installer, if you don't own any SkyX on your machine at all, is this one right here, and you'll find it as always underneath this sidebar for Professional Edition for Macintosh. And you'll see that this will install the SkyX Professional version 10.30 build 8461. So you're going to download this file and you're going to install it. After you install that version, the next thing that you might consider doing is bringing it up to the latest update. Now, the latest update is considered to be kind of the latest version for normal users. There's some conditions on that though. So you'll see that this latest update will bring it anywhere from 10.1.6 or higher through 10.3 up to version 10.5.0 build 10.305. Now I find that 10.305 is actually a really solid build and I use it for my production machine outside. But there may be things that you want in a newer version. So there are what are called daily releases. Now, the daily releases or the daily build installers are not literally daily, but for instance, this one you'll see is 10.0554. So if you want to bring yourself up to the very latest version, what you could do is you would install this one, the full installer, then you would install the latest update, which brings you to 10.305, and then on top of that you would bring up the daily build installer, which will take you up to 10.554. Now, the other thing that you're going to need eventually is you're probably going to want to do plate solving. So if you're going to do plate solving, which is known as image linking in the SkyX, you're going to also need to go ahead and download this database. Now, the database it can be found. It's known as the 10180 All Sky database. So you can just do a search for that and download it, and then you're going to put it into the astrometry folder and we're going to talk about that as well. So you might as well download all 4 of these things while you're at it on the site. So before we can actually use the SkyX Professional, we have to configure the environment in a number of ways. And we also have to set it up for the particular devices that we're going to use. And we talked about those in the previous section. The first thing that I like to do, though, is to go ahead and rig the environment up so that the display is the way I like it and has the toolbars and the stuff that I want. Now, just realize that what I like is not necessarily what you like. Everyone has different needs and different preferences. So I'm going to show you what I do when I install the SkyX Professional, and maybe you can use as a jumping off point for your own system. You might want things to be different. That's perfectly fine. It's a very flexible program, and that's exactly, one of the joys of it is that you can set it up however you want. Now, for the purposes of this video, I've gone ahead and downloaded the SkyX Professional, and I'm going to go ahead and I've already entered the serial numbers for both the program itself as well as the camera add-on. So we're just going to go straight into configuration. That I do when I start up the SkyX Professional after a clean install is I declutter it. Like a lot of imagers, I work off of a laptop or I work off of a computer that is shared. So I do a screen share through VNC or through the built-in screen sharing program. Now this is the way SkyX comes up out of the box pretty much. You've got the full color chart back here. You've got the black GUI, and you've got lots of icons and things like that. So the first step for me is to declutter, and on the Macintosh you do that through Preferences, which is located under the SkyX menu. If you're using a Windows computer, Preferences is located underneath Edit, but here I am on OS X. So the first thing that I do is I clean up the toolbars. First of all, the imaging system toolbar over here, it's cute, but for me it's useless, so I kill that. The next thing is objects, kill that, don't need that. I leave date and time because sometimes I actually will adjust the date and time to see what's going on. Field of view toolbar, useless for imaging. Now I do use the look toolbar because I like to be able to change directions quickly when I'm syncing the mount. The other thing I do here is I go ahead and I got it by default with the text underneath the icon. Well, that takes up a lot of real estate, and I can't decipher what the heck the icons mean. So I just go with text only, and that frees up some additional space. Now, other things that I do while I'm in Preferences is I click over here to Advanced. Now, there's a number of things that are useful through here, and you should look. The first thing to do is this target frame rate, which updates the screen. It tells you how frequently the screen is redrawn. It's important to have a fast update if you're using it as a planetarium. If you're using it for imaging, especially on an older computer, you really don't want it to run at a high speed because it's going to waste a lot of CPU time, run up your fan, and destroy your battery. So you can make this a much smaller number, like 2 or like 1. Or even on this old Macintosh I'm using right now, which is a 2009 model, I'll set it to 0, which will just update it when it needs to be updated. Now, the other thing that I'll do is I'll come down here and I'll look through here and see what else. I don't really like the startup sound, so I turn that off. The splash screen is kind of useless, but I'll leave it anyways. The black box recorder only works on Windows. It's a way of recording details in case there's a crash, but it doesn't really do anything on OS X. Now this enable dark theme, if you're outdoors using the laptop, you might want to enable the dark theme because it'll cut down on glare and light trespass. But if you're indoors, you don't really need it. I liked it for about the first 5 minutes and then I got tired of it. Now you'll have to do a restart on that for that to come back up. Now I leave these alone. Right now they're fine. I don't mess with the theater screens or the satellite tracking. I don't have any proxies. When you get into the camera though, there's some interesting things here. One of the issues is this camera user interface, the advanced camera user interface. If you come over here right now and you look at the camera tab, well I can't because I've got, yeah there we go. You can see that it's got 3 tabs, take photo, focus tools, and take a series. If you come down, well it's not on the chart right now because I have this open, but the reality is that in the SkyX you can run 2 cameras and the 2 cameras are actually equally functional, but one is known as the imaging camera and one is known as the guiding camera. And that's just a naming convention. The reality is that both of them can do both functions. And so, for instance, I might want someday for some reason to guide off of the main camera. I also might want to take a series or something off of the auto guiding camera. Now if you set this advanced camera user interface on, it will add more tabs to each camera and it will let you do both functions. So I would suggest that you do that. Now if you happen to have a auto guider which is connected to a external guide scope which has its very own automatic focuser, then you can turn on completely separate devices for the auto guider as well. So you can have focus tools and a separate focuser. If you have everything all included like I do, it doesn't really matter. I have an off-axis guider, so that's not going to matter. The camera warm-up and cool-down timeout isn't really effective with a lot of cameras, but it is there as an option. Don't be surprised if it doesn't work. Then these automatic connections, some people use them and like them. I personally don't like them. I like to turn things on myself. I leave the auto connect for the filter wheel switched on because the filter wheel is built into the camera. But I prefer to flip through and turn on the focuser. I don't have a rotator. I'll let it go ahead and disconnect the filter wheel, but I want to turn off the focuser and the rotator myself. Now this last setting here in the All Sky image link crop settings is important. The idea is that if you're going to do an All Sky image link, the software will look at the stars in the image. Now you need enough stars in the image in order for the process to work, but if you have a lot of stars in the image, more than you need, it's going to slow the process down. So this setting was built with the assumption that if you have a lot of pixels, it's because you have a lot of camera space, if you got a big chip. And if you got a big chip, you got a big field of view, and then you're going to have a lot of stars in the field of view, and you're going to have too many, and you don't need that many. So the idea is that it will crop the image down to the 25%, the middle quarter basically, and it will plate solve off of that. Now if you have a Sony CCD camera like I do, you have a lot of pixels, but you don't have a large chip. And if you allow it to crop this to 25% when you have this many pixels, it's not going to work. The image link will often fail because you don't have enough stars. So what I actually do is I don't say 25%, I say 75%, and I let that go. And that's the setting that I use. So now I'm basically done here in preferences. And I'm going to close this. Now, at this point, there's some other changes that you can make. The chart status that tells me where I am and what time it is, pretty useless. I know where I am. Then you've got all these tabs up here, all these things that are there. Labels, that's good to know. I need to go in there and set up my sky chart sometimes, but I don't necessarily need the labels to be here all the time, so I kill that. Now find, I use find a lot. Date and time, I've got this up here if I need to change it. I don't need this. Photos, don't need that. Chart elements, don't need that sitting there taking up space. Tours, don't need that. Observe or telescope, I do need this. I'm going to leave that. The observing list, I don't need that right now. Now if you use it, you might want to leave it. Dome, well I don't have a dome, so I'm going to kill that. Camera, need that. Auto guider, notice it's a blue background to tell you you're on the auto guider. I'm going to need the auto guider. Filter wheel, I need that. Video, don't use it, gone. Video guider, don't use it, gone. Rotator, don't have one. Focuser, need one. So now I'm basically cut down to these things here. The other things that I'm going to do before I quit and restart is I'm going to, for instance, move this toolbar because it takes up too much space up here. I'm going to click on it and I'm going to drag it over to here. So the next thing that I'm going to do is I'm going to try to clean up this chart a little bit. So, you know, I've got this cute mountain range and the day environment and the clouds and all that, but I'm an imager. I'm a form follows function guy. So the first thing that I'm going to do is pick the SkyX, and then I'm going to come in here and I'm going to turn off daylight. Don't care. I know it's daylight. I don't need it to tell me it's daylight. Then the next thing that I'm going to do is tell it map like. And it looks funny and then it resizes and there we go. Now I have these you know, cute mountains here and those are very pretty. Useless. So those are going to go away. Now some people will draw their own horizon which shows their local obstructions and things like that, but in my case it's not that important. So what I'm going to do is I do want a horizon so I can keep track of things, but I'm just going to say custom drawn, and what it'll do is I can come along here and draw one if I want, but I'm too lazy. I'm just going to say close. So now I have this gray that shows me the horizon out there. Now if you want, you can come in here and start turning on the labels for things if you want. So for instance, you might want the common star names, and you might want to go ahead for the non-stellar objects and have the M identifiers and the Caldwell identifiers and the NGC identifiers. And you may want more labels or you might want fewer labels. That's kind of an issue of personal taste. Now I'm done in labels. But if I zoom in, for instance, now I can kind of see what's going on with the objects here. You can also turn on constellation boundaries. You can turn on the lines that'll show you declination and right ascension. But at this point, I'm going to go ahead and quit the SkyX because when it comes back up, it's going to be back in its comforting, familiar gray scheme. I've moved the computer into the backyard and hooked it up to my actual equipment. And so you'll hear all kinds of cool ambient noises like the train and cars and my neighbors sawing on things and crows that are asking me to put out peanuts. But what we're going to do is we're going to hook the SkyX to all of our equipment. So here's the SkyX. Notice that it's in its familiar gray scheme now. So my telescope is an EM200 from Takahashi. So the first thing is to click the setup button, then choose the mount. And I'm going to scroll down here and I'm going to pick Takahashi, and then I'm going to go through the list. And you see there's several Takahashis. I'm going to pick the EM200 Tema 2 because that's what I have. Now if you have a newer mount like a Tema M or a Tema Z, Bisque doesn't supply drivers specifically for those, but the Tema 2 driver works fine. The main one you have to be worried about is the Junior. If you have a Tema 2 Junior or a Tema Junior, make sure you choose a Junior driver. Then the next thing I have to do is tell it how to connect. So it knows it has a Tema, but where is it? So the Tema has a serial port, and of course modern Macintoshes don't. So I have a USB to serial converter, and I have to load the driver. It's from a company called Keyspan, and this is the driver that I'm going to use here, this USA 19H2411P1.1. That's the Keyspan driver, and I'm going to select that. And now there's some other settings that are hidden down here. So I'm going to enlarge this window and see what I've got. So I don't always want to confirm slews. I know what I'm doing. I do want to confirm syncs probably.
I'm not going to worry about pointing samples, so that's not a big deal. Then the other thing that's you want to change is this: keep telescope crosshairs visible on SkyChart. This is annoying because if it's set to be on, you can't look anywhere other than where the telescope is pointing. So if the telescope is pointing at a target and you want to go check something else out and see, say, what its magnitude is or its rise time, you can't do it because it'll pop you back to where the telescope is. So you just say no and leave it at that. And then we're going to close this and we're going to test it by connecting. And we're connected. Now automatically, you see there's the yellow mark here. The Takahashi doesn't know where it's pointing in the sky, so it always starts off with this default position. The next thing we're going to hook up is the camera. Now I have a QSI camera. So again, the same thing, camera setup, choose. I'm going to come to the QSI X2 driver. Because I'm on a Macintosh, I don't have ASCOM. So I'm going to choose X2. Now, it's a USB device, so there's nothing special. Now, while I'm in here, though, I'm going to fill out some information. I'm going to put in my name. This will get copied into the Fits folder. I'm going to define what the telescope and camera are, so it's a SVQ100 QSI 960, 690, and the focal length for the rig is 580 millimeters, and it's 100 millimeters in diameter, and I'm not going to worry about the area right now. We want it to display the temperature setting. We also want auto reverse X for gems, because what this will let it do is, if you're in the case of guiding with this camera, it will know to reverse the coordinates or the direction if you're on the other side of the meridian from where you calibrated. So this is an important feature. Now, the only time you would turn that off is if you're using a third-party automation product that will do that for you. But normally you leave that on. So we're going to close that, and for a test we're going to turn it on by connecting to it. And it's going to tell you what the temperature is. And we're going to set the temperature setup here. See, it's set, temperature's on, it's set to be 0. You can come in here and set this to whatever you want. I usually run with -10. And it'll take a while, but you can see the temperature's coming down here. Now, the other thing that we're going to want to go ahead and do while we're in here is check to make sure these settings make sense. Normally, you can set this to whatever you want, 1, 10, whatever. I usually like to give it just a second exposure delay because I'm compulsive. By default, I want it to take light frames. Now, on the Sony-based QSIs, they're pretty quiet. So for my normal activities like focusing and plate solving, I set this to fast, but I image with it on high quality. It really doesn't matter which one you choose so long as your darks are compatible. Now, if you have a Kodak KAF series QSI, you will want it on high quality because it definitely makes a difference. And then I set the reduction to auto dark because mine has a shutter. And so I want that auto dark benefit when I'm focusing and plate solving. The next thing that I'm going to do is I'm going to tell it to automatically save the photos. And I'm going to go ahead and set this up. Now, they hide the nicest options, so you have to tell it show advanced. So what I'm going to do is automatically save the folders. I'm going to create a date-based subfolder starting with number 1. Now, I'm going to start the sequence with SVQ QSI _. Now what I'm going to do is I'm going to come down here, and the date-based folder is going to be of this format, which is fine, but I don't want there to be spaces. So I'm going to make those into underscores. And the reason why I don't want spaces is because I use the command line a lot, and the spaces will get in the way. Now, if you scroll down a bit, you'll see that there's a key. These abbreviations will let you set things. So for instance, I'm always interested in the target name, and I'm always interested in the image type, and I'm interested in the filter name. So what I do is I come in here, and for the light frames, I'm going to say target name, and then underscore, and then the image type is I, and then filter name. And then I'm going to do an underscore, and it's going to fill out, you see how it says SVQ, QSI, target name, light green number. And that's what I use. Now, because I used that code, I can just fill this in for all of these. And it'll automatically make them bias, dark, or flats. And I said I did a copy paste there. And I'm going to save that code because I'm going to use it again on the auto guider in a minute. Now, up here where it says the autosave folder, I don't want it to go here. I don't want it to be buried underneath all this stuff. I want it on the desktop where it's convenient. So I'm going to create go to the desktop. I'm going to create a folder and I'm going to call it raw images. And notice I didn't use a space. And now it filled that in. So it's on my desktop called raw images. We have a siren in the background. I'm going to save that. Now the auto guider, I'm going to do the connection same way. Choose. I have a Starlight Express Lodestar. Now I have Lodestar X2. It's the same driver. You're just going to use Lodestar. Now it's a USB camera, so there's nothing fancy with controlling the settings, but there are some settings you want to do. So for instance, you want to remove hot pixels. You might also try this heuristic hot pixel detection. I use them both. Now what this will do is it'll find the hot pixels in the Lodestar because the Lodestar is a little bit of a noisy camera and it'll clean those out for you. Now probably Richard Wright will come along and tell me that I shouldn't use both of them and I should probably just use this one or that one, but I use them both and it works out fine. I also don't need the high priority downloads. Notice it's not recommended for guider cameras, so I'm going to turn that off. Same thing, I'm going to type in my name because I want the FITS files to be spelled out. And I'm going to say SVQ LSX2. And then since I'm shooting off axis, I'm also shooting f580 here. And I'm shooting through 100 millimeters, just like on the imaging camera. And then I'm going to do the same thing. I'm going to tell it to save the photos. Actually, I don't really need to save the photos right now because that'll be a lot of photos. But I'm going to set up the auto save the same way. I'm going to go ahead and I'm going to put it in a more civilized location. So instead of saying raw images, I'm going to say raw guider with an underscore. That's now my folder. I'm going to name it SVQ LSX2 underscore. And then remember how I'm going to get rid of this space because I'm compulsive. And then I'm going to fill these babies out the same way. Now, there's something else I probably forgot down here at the bottom, date format. We're not using the date format, but I want to go ahead and be compulsive about it. The other thing you want to do is remove white space from autosave file names because some of the names of targets have spaces. And I forgot to do that on the camera. So I'm going to go ahead and set that up right now. Same way. One of the secrets to not going crazy is to try to be consistent. Alright, so those are two set up. Now the filter wheel is the built-in QSI filter wheel. So I'm going to choose QSY, QSI in camera. Now, filter names. I now have to actually set the filter names. I know the way that I've organized these filters. They are, in order, they are luminance, red, green, blue, and then I go into hydrogen alpha, and then I go into oxygen 3, oxygen 3, and then I go into sulfur 2, and then I have an IDAS filter. Now you see how it gives room for these offsets? I have to go look up the offsets. You have to calculate the offsets, and there's a variety of ways of doing this. In fact, I posted a kind of a long, cumbersome explanation of this on the Bisque forum, as have other people. But I've calculated them in the past. So what I'm going to do now is I'm going to stop the recording and go look up the offsets, and I'll be right back. Okay, we're back. So I went ahead and looked up these offsets from the other computer. Remember, never take out your actual working imaging computer just for a demo. Now, luminance, because it's the base filter, has the 0 offset. Red is 7 out, green is 2 in, blue is 7 out, hydrogen alpha is 4 out, then 6, -15, and -85. You can see the IDAS is off a much larger amount than the other ones. The other ones are all Astrodon filters, and they're largely parfocal within this system, but it is a refractor, so you're going to have some slight differences. So you figure out what your offsets are, and you program those in there with your names, and then you click OK or close, and then it's connected already, and it's at the luminance. We're going to move it there just to make sure. Now, the next step is the focuser. And the focuser on mine is, this one's actually technically a Starlight Instruments Focus Boss 2, but it's really the same thing as an Optec Focus Links. Now, the Optec Focus Links can support 2 focusers off of one controller, but I only have 1, so it's focuser 1. And there's some settings down here, but these are all pretty normal. The next thing you have to do, though, is remember the Focus Boss or the Focus Links is really a serial device. It comes with a USB adapter, and so you have to have that hooked up. And the correct one for this adapter is the USB serial. And I loaded that driver in advance. I believe it comes from FTDI. So I had to download that driver and make sure that it was on the Macintosh in advance. So I'm going to say OK. Now, actually, before I say OK, notice the Focus Boss has an option of more settings. More settings lets you get into the firmware of the controller. OK, I have to actually connect to it first. That makes sense. So I'm going to say close. Now I'm going to connect. OK, I'm connected. And you can see it says the focuser position, the temperature, and then these are the controls for it. Now, what I'm going to do is just show you what's in there in the firmware. More settings. Now, my Feather Touch focuser is a 3-inch model, and it has the matching motor from Optec or from Starlight Instruments. And it uses the Quick Sync FT high-speed focuser type. And then you can set the sync position to any step you want. Right now it's at 4,000. You can put it whatever you want. You can empirically measure it if you want. You can change the brightness. Now this is key, backlash. This focuser has very little backlash, but there's a tiny bit that's measurable. Many focuser brands don't bother with a backlash compensation, primarily because people either don't notice the problem because of the size of their critical focus zone, or maybe because they're used to using Focus Max, which always moves the focuser in the same direction. And I've heard rumors that this idea will be coming to the SkyX in the next release of At Focus. But currently, At Focus moves the focuser in 2 directions. And if you've got mechanical slop in one of those directions, then you may need to adjust the backlash. So that's why it's nice to actually have a focus controller that can handle that for you rather than just assuming the best. It also has built-in temperature compensation, which if you can determine the slope for your temperature curve, you can build it in and just have it run automatically without worrying about it. I don't happen to use it, but I do know other people that do use it. So now everything's set up. Now you'll notice there's an additional tab, which is a TEMA-specific tab that gets added because I'm running an EM200. Other mounts have a specific tab as well. The one thing that I want to change in here is the guide rate. It's set at 99%. That's a little high for me, so I'm going to set these to 75% and then set the guide rate. There are a few other useful things in here. For instance, you can determine what power source it's using. You can sync it at zenith. You You can also check which side of the meridian the optical tube is on, but that's actually on a status screen, which you can't get to because the tab is hidden due to the small size of this screen. If we were running a larger screen, you could get there. But the default for the TEMA is to have the optical tube on the west side. So if you don't need to change that, you don't really need to get into that other tab. So on that note, we're going to shut the system down, basically going back through and disconnecting. I'm not going to disconnect the filter wheel because that gets disconnected with the camera. Disconnect, disconnect, and disconnect. One final thing I want to do now before it gets to be dark is I want to add the AllSky image link database. So remember earlier I talked about doing plate solves and AllSky image solves, and I use that a lot. I use it in my automation script, but I also use it to synchronize my mount's go-to, and so we have to have that. And it goes in a very specific place. It goes into the application support folder. Now each platform puts it in a different place, but on OS X it's hidden inside of your personal library file. The problem is that that's hidden. So, you know, if you're using the Finder, you have the Go menu up here and you have these shortcuts for folders. Now if you hold down the Option key, you'll notice that Library appears. So you hold down the Option key, select Library. Now you have a bunch of application-oriented things. You go into Application Support. Then you're going to find Software Bisque, which is right here. Then you're going to go into the SkyX Professional. And then you'll see that there's a folder called Astrometry. Astrometry. So you're going to open up Astrometry, and you'll see that it's blank. Now, if you've gone ahead and downloaded the AllSky database, like I suggested that you did, you'll have it. You're going to copy it into this Astrometry folder. And now it's there, and it's going to be ready for you to use to blind plate solve your images. So I'm going to quit here, and we're going to resume in a little while when it gets to be dark.
Hi, welcome back. I actually did a bait and switch on y'all. Instead of using the laptop that's running build 10554 that we set up earlier, I'm actually connecting to a Macintosh Mini in the backyard, and I'm sitting inside. So the Macintosh Mini is running a version of the SkyX Professional, which is a little older. It's running 10305, and you can see a few little differences, like the color is actually correct in 10305. I think that'll probably get changed in an upgrade, but right now this is the version that I usually use. So the TEMA is outside right now. Its optical tube is on the west. It's pointing to the eastern sky, and the sidereal drive is on. So I've connected to it. Now I'm going to connect to the QSI camera. And now I'm going to double check that the filter wheel's there. I'm going to go ahead and set the filter to clear, because which is really luminance. I just call it clear for a historical reason. It's more correctly called luminance. So I'm going to move that filter. Then I'm going to connect to the lodestar. And then I'm going to connect to the focuser. Now, the first thing that I have to do is find out, is the camera focused well enough to do anything? So I'm going to start that by taking a 10-second exposure right now, and I'm going to go ahead and turn the auto dark feature on, and I'm going to take that shot. Now, it's not quite dark yet, but it's getting there. I'm also going to go ahead and move this into full screen, so hopefully it'll be a little easier to read. And there's the image. Okay, so now you can see the stars are there. They look a little bloated. So what we're going to do is we're going to rough focus the system. And I'm going to do that by picking one of these stars, and I'm going to draw a subframe. I'm going to choose the subframe tool, and I'm just going to draw that star. And now what I'm going to do is come to Focus Tools. I'm going to tell it to just take a 2-second exposure, and it's going to do it continuously. Now, I have the feeling that, you can see it's out of focus. I have the feeling that it's out of focus too far inward because I imaged with it last time, and during the night the focusing tube moved in. And so now I have to move the draw tube out. Now it's 18 degrees. I'm going to bet it probably has to be around 4,500 or something like that. But let's move it to 4,300 here and see if that improves the situation. So hopefully that will tighten that star down, and it'll be, yep, there we go. Look at that. So you kind of learn that instinct, when you have used the system for a while. If you're getting used to it, though, you may have to hunt around, move in small steps, and figure out how to get it down fairly tight. Now, what I'm going to do now, since I'm kind of in focus, is I'm going to abort this. It's not perfect focus, but it's better. I'm going to go ahead and take a photo, full frame. I'm going to turn the subframe off and take that 10-second shot, which of course is going to use an auto dark. So it'll probably have to run another auto dark for me because the temperature's changed and the exposure rates changed and things like that. Looks like we have a cloud. Of course there would be a cloud overhead because I'm trying to show you something, and if I stop imaging it would be very inconvenient. But just in case, we're going to see if we see anything. Sometimes the SkyX has a remarkable ability to plate solve, even when there's stuff in the way. See, it found some stars. It's going through the database, and it succeeded. Now that's pretty remarkable, the fact that this much of the sky, of the image really, is clouded over, but it still figured out where we are. And you can see, I used the all sky, and I used the all sky search, and it didn't need to know where it was, but it tells you the coordinates for the center of the picture. It gives you the image scale here. And so what I'm going to do is close this, and you can see that it has created a box. Now what it will do normally is it will show you the actual image, but I have that feature switched off. The way you do that actually is you come underneath the image link command here, and you come over to search, and you just tell it don't show the photo. That's all you have to do. So now I'm going to click somewhere on this picture, but not on a target. I don't want to click a galaxy or a star. You can click a white space. Now you see there, boom, selected the center. So now the center of this photo is the selected item. I'm going to go up here to the telescope tab, and I'm going to tell it to do a star synchronization. But I'm not going to synchronize on a star. I'm going to synchronize on the image link photo. I'm going to click sync. And now you'll see the yellow bullseye shows up here too. So we're now synchronized with the go-to system. So in a minute, we're going to see if the clouds go away, and then we'll go ahead and run at focus 2. The clouds have cleared out very slightly, so we're going to try to do a quick at focus 2 run this time without clouds. So the way I'm going to run this is that focus 2 command is underneath the camera tab, and then up here you find focus tools. It's right there. Now there's an at focus 2 button which brings up a dialog box. There's several discussions on the Bisque forum about how to set these fields, and also how to set this exposure information here. But the catch is you do want it to be automated. That should be your end goal. So you determine your focus range basically by following the math in the book, and then the manual, and then working your way down. You determine the samples kind of empirically. I use 9. A number of people I know use 7. Some people use 11. The book says you can use less. I don't believe that. I've not had consistent luck with 4 or 5 samples. Averaging, if you're in a perfect seeing location like West Florida, maybe you can use 1. If you're in most of the United States, you should probably use 3, which means it'll take 3 exposures at each sample location and average them. If you're in Colorado where you have terrible seeing or some other place like that, go on up to 5. Now, I don't know if you would ever need more than 5. Maybe your seeing would be really horrible if you did. But don't bother with 2. 2 is popular, but statistically 2 doesn't really make any sense because it doesn't allow the system to sort of average out what the truth is. It's not, you don't have enough data from that. You can determine if something's wrong, but you can't really get an answer. So with these values, I'm going to kick off at focus 2, and then we're going to watch in the graph to see what happens. So there's the image up. There's some clouds, but you can see that star dead center. And we'll see what it does with the clouds. So you can watch its progress here. You can see the exposures down here. So this is the brightness value here. And you can see it was started out bright, it went dim. This is the half flux diameter history here. Actually, this is a spurious thing that was in there in a previous attempt. And then you can kind of watch. Now, this is the the V curve here that shows the positions versus the HFD, or the sharpness of the star. Now remember, I started this a moment ago and I aborted it. So we might have some kind of bogus data in the buffer here. But you can kind of chart what's going on here. You know, the brightness is getting up brighter as it focuses more and more of the star's light on fewer pixels. Then it drops down again as it changes focus. And then you kind of have the inverse of this phenomenon going on with the HFD value. And then you can see how the HFD value maps out against the position. Now you can watch as the telescope goes back through. It's already past ideal focus and it's working its way outward now. Again, you would ideally do this in a situation where you didn't have clouds. So this is not really the best thing. But I find that at focus 2 is still pretty resilient about finding a decent focus level for you, or a focus point. Now you see it says it's successful, moving to focus. This is the only sign of success that you will get out of the system. If there's a failure, it will throw up a non-modal dialog box. So that's how you run at focus 2. Next, we'll move on to taking a few pictures and calibrating the. Hopefully the clouds will stay away while we try to calibrate the guider. Now, calibrating the guider in SkyX is a little finicky and it scares a lot of people. But once you learn the trick, it's not that bad. It's just very simple-minded. So what we're going to do is go to the Auto Guider here, the tab, and then we're going to come up to the Auto Guide tab, and we're just going to take a photo. Now, I use 5-second exposures because that's my go-to exposure. You'll notice that I also fully calibrate my lodestar with darks and flats, but you don't really have to do that so long as you use the hot pixel killer that Richard wrote for us. So first of all, I'm going to take a picture and get the field and see what I've got there to calibrate on. And so it's a little cloudy out still. Normally I would have more stars than this, but I got this one, so I'll take it. The first thing, though, is to realize that there might be brighter stars outside of the field of view. And I don't want those intruding in, because what happens is the SkyX will take a picture and it will measure the location of the star, then it will move the mount, and it will then measure where the star has moved in the new photo, and that's how it determines how far it moves, the mount moves per second of guide pulse. And if, you know, a bright star that's lying off the image, say over here somewhere, suddenly intrudes, then it's going to throw it off, because what the SkyX does is it just looks for the brightest image. Brightest object in the field. It says, all right, that's the brightest object, that's the star. So you can mitigate that by drawing a subframe. So I'm coming up here to this tool, and I'm going to just basically draw a box around that star that I want to use to calibrate, and I'm going to come over here and choose Calibrate. Now, I'm not using a paramount. I'm using a Takahashi Tema, and I'm using Pulse Guide, which means I don't have the ST4 cable hooked up to it for relays. I'm guiding through the mount driver. So I'm going to click OK, and it'll take a picture and determine what's the brightest thing, which will hopefully be the star in case a cloud washes over us. Now you see up here, it's moving in the X plus direction. It's moving for 15 seconds, and then it will take another 5-second exposure. And you see how it's moved. Now the object is more to the left, and there's a little green arrow that's shown you. Now it'll backtrack now in the reverse direction for the same distance, and hopefully the star will wind up in the same place, or there won't be a hot pixel or anything else that'll get in the way. Boom. Okay, it's back where it was. Now it's going to move in the Y plus direction in the mount, again for 15 seconds. And there's the star. And you see it's got a nice, orthogonal 90-degree angle. Now remember, it doesn't have to be perfect. You don't have to have perfect axes. You can have a little tilt to the camera and it'll be just fine. It's better if it's not ridiculous. So you can see it popped up this window back here. It said it calibrated fine. And these are the vectors. You can see that the guide camera is not perfectly in line with the axes of the mount direction, but that's okay. And these are relatively, relatively close. It's a little strange that this is 4.8 versus 4.5, but, it is a low resolution load star. I'll take it. It's close enough. So I will accept that guiding has now worked. Now, if I really wanted to guide, for instance, on something, I'll turn the subframe off, and I'll take a photo. And there's a couple of things that you need to look at. One is, you see we've got more cloud action. There's our star right there. But you have this setup. Guiding has to be, you have to have parameters for your guide camera. You can't just use it. So these look familiar, 15 seconds of calibration time. But we have some other settings in here. We have the minimum move and the maximum move and the aggressiveness, and then also whether you're going to pulse guide or whether you're going to use relays, or on a Paramount you would use direct guide. But on the TEM I'm going to pulse guide. Now there's many thoughts about how to set these things, but there's an online calculator. If you look it up, it's on a website. Look up CCDware Auto Guiding Calculator. And you can put in the information about your image scale, how many arc seconds per pixel your guider sees, and your imager as well. And it'll give you some suggestions that are starting points for minimum and maximum moves here. And then aggressiveness is your main way to combat bad seeing. If you've got really bad seeing and your stars are jerking around, you don't want your guider to sympathetically jerk around chasing them, so you kind of tell it to relax a little by backing down the aggressiveness. A lot of people guide with very, very low aggressive settings, especially on Paramounts, but Paramounts don't need much correction, so you're going to have to kind of figure this one out for yourself. So at this point, what I'm going to do is I'm going to guide on this star. Now you can tell it to auto-find, but don't do that. Look over here, find the star that looks best for you. In this case, it's easy. There's only one. And then you're going to double-click it, and you're going to come over here and say auto-guide. And it's going to start guiding. And there's the picture. Now this is terrible looking because I have clouds out there. But you can still see the centroid, and it tells you here this is the error. Now you can also look at the graph if you click the graph button, and this will tell you your error both in pixels and in arc seconds. And you can kind of see the line as it moves along. Now the guiding graph can be very useful for diagnostics and to make sure that it's doing what you want it to do. But you don't need to keep your nose in the guiding chart. It's going to kind of, it's going to have good and bad days and moments. And you can really drive yourself crazy chasing guiding. And every once in a while here in Colorado, I just think, gosh, I got to reset my guider settings because my guiding is all over the place. And then some night I'll have really clear seeing, or clear skies and nice seeing, and it guides beautifully. And every once in a while I'll take a screen capture of that just to remind me what nice guiding looks like, because I don't always have it here in Colorado. So we're guiding. Now, if we wanted to go take a picture of something, then we could, switch over to the camera tab, and this guider is going to keep running in the background. Right now, for instance, if I wanted to take a picture of some object, I could, set the exposure to whatever I wanted. Now, what we'll do in a moment is we're going to come back and we'll actually slew to a target using closed loop slew, and we'll set up this process and take a quick exposure so you can see what that's like. For now, though, I'm going to stop my auto guider and I'm going to stop recording this because the file is getting big. We're going to try to put all this together and actually take some images of something interesting that we really want to take an image of. So remembering that tonight's a little cloudy, so it's a good time for this, I'm going to choose M108. Now, what I did is I kind of, went ahead and pre-moved the telescope so it's sort of pointing towards the north, but it's not a M108 exactly. So what I'm going to do here is I've got M108, I'm going to put it into the field, and I'm going to type find. Now, you see the red bullseye says where M108 is, and the yellow one says where the telescope is. Now, I could just hit slew, and it would move the telescope over there. And because we've synchronized our go-to to the night sky, it would probably be pretty accurate, but I want it to be dead accurate. So I'm going to use this thing called closed loop slew. And closed loop slew is a plate solve enabled version of slewing. It'll slew to where the mount thinks M108 is. It will take a picture. It'll plate solve that picture to determine where it actually is, and then it will calculate where it needs to move to correct itself. So you see the yellow bullseye is closing in on the red bullseye, and when it centers, what's going to happen is it will then take a picture. And it's going to take about a 10-second exposure here. And then it'll plate solve that. And because it's 10 seconds and M108 is small, you're not going to see a whole lot here. You probably won't see the object, but you don't have to. You have stars that are in the field, and it's working off those stars. Now, if you look, for instance, right there is the star, and we'll see how accurate it was. And it shifted very slightly, but not much. And you can again see how it oriented that. This is the orientation for it. And it's pretty accurate right now because we didn't move very far in the night sky. So now I want to go ahead and set up the auto guider. I'm going to take a photo. And remember, it's off axis from the main telescope. And that looks like a reasonable guide star right there, dead center. So I'm going to click on that sucker and select it. Now, in Windows and I believe Linux, a box will pop up around it. For some reason in OS X, that box doesn't show up. And I'm going to come over here and click on Auto Guide. Remember, don't use the Auto Find Guide Star. What it does is it searches out the brightest thing in the field. So you can see the error up here right now. And I'm going to just let it go. And I'm going to drag this window down here so it doesn't bother us and go back to the main camera. Now, I could, for instance, do an auto dark, but really if I'm doing serious imaging, I'm going to want to calibrate it in PixInsight or something else. So I'm going to say none. And ideally, if I were serious, I would go to higher image quality rather than faster. But let's go ahead and, take an image and see if we can see anything. We may not be able to just because it's cloudy out. But we've got it imaging and we've got the guider working. Now, this is fine for taking one image at a time, but you will eventually get to the point where you're going to want to take more than one picture at a time, or where you're going to want to cycle through filters, and you're going to want it to change the filters for you automatically. And so this is where the SkyX is a little limited. It has a take series command, and I'll show you that in just a moment. Oh, check that out. Something interesting flew across the field. But you can barely see the hint of the galaxy. It's right in there. Now, of course, if we were going to take many, many pictures during the night, we could work this out, by pixel rejection for calibration. But the take series command is located here on this tab. And it works like a spreadsheet. You add series and you remove them, and you go through and you fill out the fields. So say I want to take 30 seconds, and I want it to be one by one binning, light frame, red filter. I want to do 2 of them, and I can choose faster or higher download, and I don't want it to do any calibration on its own. And then I'm going to do the exact same thing with green and the exact same thing with blue. And remember, if we want to make sure that down here, for instance, we have the automatically save photos. And you'll notice that all the photos we're taking are being written out into this raw folder, raw images folder where we told it to go. And you'll see the images for closed loop slews go into their own folder so they don't intermingle with your pictures. And the @Focus2 run images go into their own folder as well. So at the end of the night, all your stuff is just kept right there. It's pretty handy. Now remember, all while we're talking and deliberating, the auto guider is still working here, and you can see its error level right there. It's not bad. At least it's not bad for me here in Denver. So if I wanted to set this thing off, I would just program whatever filters and durations and repeats I wanted, and I would click the Take a Series button. Now, I'm not going to do that. We're going to quit, and then I'll come back and talk briefly about automation on OS X. But the thing about Take a Series is you can do a lot with it. Where you run into problems with Take a Series is if you are imaging close to the meridian, because Take a Series will not flip the mount. Take a Series doesn't control the guider. Take a Series does not refocus the camera. So it's great for taking a group of images when you're not going to be, letting it run for a really long time unattended. So that it's a very useful tool. By the way, it does do dithering. The dithering command is down here if you tell it to do it. You say exposure delay, what kind of dithering you want. You can tell it to dither. I don't use Take a Series much for actual imaging, so I don't really mess with the dithering. But you can set how many pixels. You can tell it like how far you want it to. How ideally settled it needs to be before it resumes imaging, and whether there's any kind of standard reduction. So you have a lot of control here. But for right now, I'm going to turn off the auto guider, and we'll be back in a moment. The last thing that I wanted to talk about for kind of wrap up this presentation is kind of the topic of automation. So as you've come along with us today, you've seen a lot of things. You've seen guiding, you've seen focusing, you've seen closed loop slews, you've seen synchronizing your go-to system. There's a lot out there that's required to get your astrophotography system up and running. But eventually the novelty of watching it go through the paces wears off, and you'd kind of maybe like to sleep or spend time with your loved ones or watch TV or tune into the Astro Imaging channel. And you're going to want some kind of automation. Now, the SkyX is designed to give you exquisite control over all of your equipment, but it does kind of make the assumption that you have an operator, at the stick who's watching it and is going to tell it what to do. Now, this is where the role of automation software comes in. Out of the box, at least at the moment, the SkyX doesn't do automation. It has the take a series command, which is a great feature, but it's not going to run the system all night long, and it's not going to make any decisions for you or decisions in your absence. So this is where programs like CCD Commander and Sequence Generator Pro all come in. And each one of these programs has its pros and cons. But for me, as a Macintosh and Linux user, the big problem with all of these products is that they run on Windows. So if you are running on a Macintosh or Linux or on Windows and you just want something a little less nice, I actually have a set of automation scripts which are available from my download directory on the SkyX's, on the Bisque website. And again, it's command line oriented, so you don't need to be afraid. You'll just put on your big boy pants and type a few commands. But what we're going to do is I want to take a few sample images of this Galaxy NGC 2841. Now, because we have clouds, it's really a terrible night for imaging, but it should be okay to demonstrate this for you. So my script lives in this main script directory, which I keep on my desktop. And the main program is called Run Target. I'll go ahead and make this full screen. And then it has some documentation, and you need to read the documentation if you want to use my script. Read the documentation, and it'll tell you how to configure 2 or 3 variables to make it work better for your system. But what we're going to do is we're going to open up the terminal system here. Now, the great thing about the modern Macintosh is that you have this nice graphical interface, but underneath it beats a complete Unix system, complete with a command line system. So I'm going to go into the directory that represents my desktop, which is what you see out there, and then I'm going to go into the main target or main script directory. And if I look and see what's in the directory with the ls command, you can see that there's the 4 files I just showed you in the Finder. So what I'm going to do is I'm going to tell it to run target, and the target name is NGC 2841. That's the target I want to run tonight. And just for fun, just to show you, kind of the gist of how it works, we're going to take some really trivial exposures. I'm going to tell it to take 2 10-second long exposures through luminance. Now I know in my filter wheel, remember when we set it up, luminance was the first filter in the wheel. And then I'm going to take 1 of red, 1 of green, and that's all I'm going to do for the sake of this demonstration. And then I'm going to hit return. Now it's going to come up and say, yeah, you're running on a Macintosh. The target is NGC 2841, and it reads back what you're going to do. Clear, red, green, tells you how many exposures. And because these are all really short, the exposure is really less than a minute. And then it gives you 10 seconds to kill it if it's not right. But the first thing that it does is it looks up the target, NGC 2841, and it finds it in the database. The next thing that it does is it closed loop slews. Now you'll notice that the yellow has not moved, but that's because of a quirk of the way my software works with a TEMA mount. It doesn't do any screen updates while it's slewing. If you had a more modern mount, it would not do that. I was hoping, there we go. I wanted to watch what the camera's doing while it's running. So you'll see that it's updated. It's now on target. It's taking the first image for the closed loop slew. It did its adjustment. Now it's taking a confirmatory picture to prove that it is where it's supposed to be. Which you're not seeing because all these image photos are hidden when the SkyX is a background application. It's kind of a glitch with OS X right now. That shows where it is on the map. That shows the frame the rectangular picture. Now you see the red dot right now is actually the star that's going to go focus on, because it's going to do a focus routine before it starts imaging. So as you see, there's a lot of stuff that has to get done. So, you know, when folks begrudge paying $100 for Sequence Generator Pro or something like that, they need to think about it. A lot of work goes into automation programs. And you can watch the camera read out up there as it's taking all of these exposures that it needs for focusing. Now, if we want, for instance, we can bring the SkyX into the foreground, and you can see how its progress is working here. But you see, normally you wouldn't be here watching it. You would be off in bed. And again, if you're living in a part of the country that doesn't have such bad seeing, then you wouldn't have to take 5 averages for each sample position. And your focusing would go a little faster. So again, 45 images here in order to do a at focus 2 run on my system. And you can watch that maximum ADU count get less and less as it starts to defocus that star. And you see it just drop from 2,000 and something to 1,000. Now it said it was successful. And that's all you're going to get. Now the log will then report that it was successful, and the log will tell you the focuser position, the temperature of the focuser, and then the star that it used to focus on. Now it's going to slew back to the target, because you know you want to make sure that that target is dead center of your chip. Now, if you want to frame the target artistically, you can do so by feeding it a set of coordinates rather than a target name. And that was the first exposure. It did its analysis. And then it has to do any kind of mount movement, and then it takes a second exposure to verify. And it was successful. And so it says it's successfully slewed, it's on target, and it gives you a readout of the image scale, 1.305 arc seconds per pixel. The mount direction, it's facing west, it's at an altitude of 68 degrees. Now it's taken a picture through the guide camera, and it's found that the best guide star candidate was at that particular coordinate. The next thing that it did is it took 3 rapid pictures of the guide star and it measured it to determine how bright it was. And if it's kind of dim, it will bump it up a second to say 6 seconds in this case. And if it's really bright, it'll knock it down a second. Now what it's doing now is it's guiding. And it's reading the error. So these 2 columns represent error. And when it gets its error down to an acceptable limit 5 times in a row, it will start to image. Now the acceptable limit is based on a ratio of the guide camera image scale to the imaging camera image scale. The idea is that it shouldn't be moving more than 1 imaging target pixel. So your slop should be maintained in that. So you see it locked on, and now it's reporting the temperature, and it's taking the image through the clear filter. Now again, only 10 seconds, so this was a trivial example. Normally I would image for 3 minutes or something like that. Now what it's going to do is it's downloading the image, and it took a little longer to download it because it automatically moved it into high quality mode. Now these are the stats. It's telling you that it took it through the clear filter, give you the temperature, the focuser position, and it also gave you an FWHM value in arc seconds. So 4.57 arc seconds. Not brilliant, not terrible. Truthfully, we're shooting through clouds, so it's actually probably a little lower than it normally would be because the clouds kind of act like a filter for some of the errant starlight that's dancing around. And now it's taking the picture through red, and you can see what it did there. Gave you the statistics. And you can see that the focuser position is slightly different. And that's because it used the offset value in that table that we set earlier when we named the filters. It automatically moved the focuser a little bit to compensate for the fact that light moves through the refractor in different ways in different color channels. And then it gave you the FWHM, which is a little bit tighter. Also remember, a filter like red will also screen out some of that starlight, so there's a little bit less movement. Now it took a shot through green. Now we're back up to a high FWHM again. But you can see again, the focuser position is a little bit different. It's confirming each time after each image that the guider is still tracking, that the error is not very high. Now at this point what would happen is if it was getting light in the morning, it would park the mount. If the mount crossed the meridian, it would turn off the guider, flip, reacquire a guide star on the other side, and resume. If a temperature change or a length of time that you set has occurred since the last focusing run, it would go off and it would refocus itself. Now none of those things are happening, so it just went ahead and dithered the mount. And it dithers the mount a random direction and distance each time. So in this case, it dithered it 7.3 arc seconds north and 11.5 arc seconds east. And then the exact distance it moves will also depend on your declination. And then it found, took another image, found the guide star. It's trying to let the guider settle here. And it's having a little trouble. That 53 is still a little high. Maybe there we go. That guider correction kicked in and moved it. It's only got one more image. This process would work exactly the same on Linux, and it actually works the same on the Raspberry Pi, and it works the same on Windows. If you want to run this script on Windows, you're going to have to download the Windows subsystem for Linux if you're running Windows 10, or you'll have to download the Cygwin system, which provides a Unix shell environment to run on Windows. Now this will be the last image that it takes. And so what it will do at this point is it will go park the mount. And it will disconnect the cameras, turn off the cooling, and it will now slew to Kocheb, which you can see is just lit up here red. Kocheb is very, very close because we're up by the North Celestial Pole. If you're in the Northern Hemisphere, it will slew to Kocheb, wherever Kocheb is, and then it will turn off the sidereal tracking motor and wait for you. And if you're in the Southern Hemisphere, it'll slew south. The idea is to point it away from the sun. If the sun should rise in the morning before you get out and put away your gear or cover it up. So I tell you, automation of the SkyX, it's a beautiful thing. It's really, really nice to have the confidence in your gear and your software to kick it off at night go inside, and then when you come out in the morning, it's parked and you've got 90 images sitting in a folder waiting for you to, move and analyze. So on that note, I'm going to close the presentation down. I hope that you had an interesting time, and I hope that it might have been beneficial to you. If you have any questions about anything that I've said or done, feel free to reach out to me on the Bisque website. Just look up Ken Sturrock and send me an email. Just realize there's no way to make a video that will actually answer all of your questions and will cover all of your gear. Even though people like looking at videos, it's really a very limited way to do things. So on that note, thank you very much. I appreciate your patience and your time.